Yes, good evening guys to all of you. First of all, please tell me am I properly audible and visible to all of you or not. So guys, this is a session specifically for GATE 2024 XC candidates. Yes, I feel am I properly audible and visible to all of you. So guys, this session we are going to discuss about 25 most important previous year's questions of GATE XC paper. Okay, and as first of all you should be aware of one thing. Whenever we talk about in XC, like during the exam you are going to choose two subjects. Okay, so whatever those two paper actually you are going to select is, as I said, whenever you say solid mechanics, many students feel that it is only strength of material, but I would like to make one thing clear that this solid mechanics is having, yes, strength of material it is having, second is engineering mechanics, third is vibrations. Okay, and some very small part which is not mentioned like Coriolis, acceleration, these kind of things are also coming sometime. So guys, these are the things which are said to be the part of syllabus if you see these three topics. Okay, so we are going to start. This is some introduction about myself guys, and this is the Telegram channel Mechanical by Dheeraj Sardana, where you will get the PDF of this session. Yes, Ajay, hi dear, how are you? And guys, then this is about those students who are preparing for engineering services examination. For them already non-tech express is going on. For that non-technical parts sessions are going to be there. Okay, and if you see that is already started from 7th of February, every day one session is going on. You can see tomorrow also you guys are having a session. Yes, Shreyas, good evening. So how was your GATE mechanical paper? Shreyas, Ajay, you didn't tell me how was your paper. So guys, now this question we are having the first question. This is from engineering mechanics, from projectile motion. This is the PYQ of GATE XC paper only. So you can try and solve this question. And guys, this question says a projectile is fired from a point P at an angle of 45 degree. So you can see this angle is 45 degree. They have given it. And they said that if g is the acceleration due to gravity, then the speed required to reach a point Q on the horizontal surface at a distance r from the point P. That's great, Ajay. What about you, Shreyas? And here I would like to tell you, in this question we are going to use the formula for range. Very good, Ajay. So I am happy to see that. Hope you guys would be getting good marks, good rank. So I feel there was nothing like which you were not aware of in the exam. Okay, you can solve it guys and give me the answer for the first question. Then we will be starting the next one. Yes, everybody, what would be the answer for this? Everybody, you need to apply the formula for range. Formula for range. Formula for range. Okay, Jisk is saying the answer to be C. Jisk is saying the answer to be C. Anybody else? Do you know the formula for range? Do you know the formula for range? This is the range. Yes. It is u square by. Okay, Ajay is saying A is the answer. First of all, tell me the formula for range, guys. First of all, tell me the formula for range. Formula for range. Okay, Ajay is saying u square, okay, sine to theta by g. Okay, u square sine to theta by g. Okay. So guys, when we are talking about u square sine to theta divided by g, it is not 2u square, it is u square sine to theta by g. So when we are talking about velocity, they have given as v naught. And when you will be putting this value, you would be getting the answer to be, let us say this is r is given to us. And you would be getting the value of what? You need to find out a projectile is fired at an angle, the speed you need to find out. Okay, so you need to find out the speed only. So you would be getting gr divided by sine into 2 into 45 degree. So I feel the answer will be coming out to be what? I feel it will be coming out to be B. Yes or no? Please tell me, guys. Is it correct? Please tell me. And if you have any doubt in the formula of range, you can also use S is equals to ut plus half at square. So when you will be using this, you know that in the x direction we are getting the range. So S is coming out to be ux into t. Okay. So you can write ux is u cos theta, and then t is the total time of flight. Okay. So for that also you can see when we are talking about the time of flight, you know this total height is h. And when we are talking about the time of flight, you can once again use in the y direction as s will be equals to 0, s is equals to ut plus half at square. So when you would be going for this, you would be getting the time of flight as s is going to be 0. You know that in the y direction is u sine theta. So that you need to find out the value of t. Okay, you can find out the t here, put it here. You would be getting the answer as u square by g sine 2 theta. I feel everybody understood this, how to do this. Is it clear? Yes. Very good, Shreyas. So this is how we can do. Moving further to the next question, guys. The state of stress at a point. This is from strength of material. So the state of stress at a point in a loaded body is sigma xx this, sigma y this, tau xy this. The sum of the principal stresses at any point is. So solve this question, guys. This is from strength of material. Then we are moving further. Question from strength of material. Total 25 questions we will do from all the parts. They are previous year's questions which already appeared in papers. So they are nothing new. And guys, I would like to tell you that tomorrow we are also going to meet those who are appearing for engineering services. For them, engineering mathematics session will be coming tomorrow at 9 p.m. Okay, so there also I will be solving around 20 questions. Okay, guys, the state of stress at a point in a loaded body given as this, you need to find out the sum of principal stresses. Thanks, Moodley, for your wonderful words. This is just by God grace you are having when you can say whenever we are going to do this by looking at the syllabus, by looking at the previous year's questions based on that. Okay, Jisk is saying 100, Ajay is saying C. Okay, answer is C. How you will be doing? You know that sigma xx plus sigma yy, sigma 1 plus sigma 2 is equals to sigma theta plus 90. This is a property which tells us that the summation of normal stresses at any two planes which are perpendicular to each other is always going to be same. So you can say 60 plus 40 is going to be the answer. Answer will be 100 MPa. That's a very good question. Moving to the third question. This is once again from strength of material. Very good, Divit. This is the strength of material once again. A L-shaped elastic member with flexural rigidity EI is loaded as shown in the figure. The total strain energy in the member due to the loading is, these are the option. Okay, and when we are talking about this is P square, let me correct it, P square, it is going to be P square B square. This is not 6, this is B, so take it as B. Okay, this is A, so don't take it at 6, this is B. Yes, try to solve it now. That's really great. I did not see that actually till now, but that's really great. Solve it, guys. Maybe in XC also you get these questions. So guys, here you need to find out the total strain energy in the member due to loading. So you know that this is A, this is B, and this is C. So strain energy total is U of AB plus U of BC. So U of AB, U of BC. Okay, this distance is B, this distance is A. So when I will be solving this, you know that when you will be taking a section like this, 1, 1. So for this section, M11 is it is going to be P into X. Okay, so you need to solve it, guys. Then you can also have M22. When you will be going for M22, for that you will be applying one force here, other force here. This and this will be making a couple like this. P into B. Okay, and then you will be finding out P into B is the moment. Okay, and you need to find out the total strain energy, which is going to be equals to M11 square dx upon 2EI plus M22 square dx upon 2EI. Okay guys, so solve it, just solve it. I'm waiting for your answer. Sir, I was in class. हाँ. Okay sir. YouTube. Okay guys, try to solve it. So as today Abhinav sir was somewhere else, that's why he couldn't join this session. So guys, can you solve it and tell me the value? I am solving it for you. First of all, you will be finding out U total, the very first strain energy. It is for AB part. So I am going to say bending moment is P into X. So P into X ka square dx upon 2EI integration from 0 to B plus for this it is 0 to A. This is P into B ka square dx upon 2EI. Okay, so when you will be solving this, it is going to be P square outside, X square will become X cube by 3. So X cube by 6EI integration from 0 to B plus this is P square B square upon 2EI into X integration from 0 to A. Now you need to solve it. Very good, Jisk, very good. Okay, no issues dear. Actually थोड़ा सा कभी कभी ना टाइपिंग एरर हो जाता है. So it is P square B cube upon 6EI plus P square B square A upon 2EI. So when we are talking about, you will be getting P square B square upon 2EI A plus B by 3. If you are getting this, this is the correct answer. If you are getting this, this is the correct answer. It is P square B square upon, this is going to be B by 3 plus A. Answer is A. I told you that B is here shown by 6. So answer will be A for this. Moving further to question number 4. Before that, I would like to tell you that on 14th of January, you guys are having a workshop, and that would be at 7:30 p.m. will be taken by Rakesh Talreja sir. This is on detailed 1-year preparation strategy for GATE 25. If you have made your mind to prepare for 25, this is the right place, and to know how the preparation should be. This will be on Byjus exam prep app only. Next question is from SFD BMD. You need to find out the maximum bending moment. You need to find out the maximum bending moment, guys. Try to solve it. Try to solve it, guys. This is a good question, and I hope you guys would be able to answer it. Good evening, Kunal. How was your paper? Was it good? First of all, I would like to give you a hint. You can find out support reaction R1, R2 first of all. Find out, then you will be able to find out the maximum bending moment. Question number 4, this is. That's great, Kunal. Solve it, guys. Solve it, solve it, solve it. Okay, I'm giving you one more hint. R1 plus R2 is the total load. 4. Summation moment about P0. When you will do this, you will be able to get R2. It will give you R2 into 2 is equals to, this is W into total load length, W into L, into the distance of that center from here is going to be once again 2. So this will give you the value of R2. Put it here, you will get the value of R1. Yes, anybody? Anybody the values of R1 and R2? Anybody the values of R1 and R2? Anybody the values of R1 and R2? Yes, guys. Okay, JISC is saying 0 and 4. So this is 0, this is 4. Is it correct? R2 is coming out to be 4. R2 is coming out to be 4. Is it correct? R2 is 4, R1 is 0. Very good. Answer is B. That is correct, JISC. B is the right answer. So once I am getting this, first of all, now I know that from P to Q, the shear force is 0. Okay. And now you can see about this point, this side load is 2 into 1. This side load is also 2 into 1. So that is for sure about R. Whenever you are coming left and coming right, the shear force will be changing its sign and bending moment will be maximum. So when you will be finding out the maximum bending moment, it will be minus Wx square by 2. You would be getting minus Wx. If I take the section here, just consider it like that. It is going to be x distance is 1 meter. 1 ka square by 2, answer will be coming out to be 1 kilonewton meter. B is the right answer. Moving further to the question number 5. This is a good question. Very good, Anuradha, Shreyas. Moving to the next question. A 10 mm thick steel rectangular plate of size 100 mm cross 200 mm is subjected to biaxial stress. Okay, sigma xx 150, sigma yy 200 as shown in the figure. The Young's modulus and Poisson ratio are 200 GP and 0.3 respectively. And you need to find out what? They are asking you the change in thickness of the plate. Okay, so you need to find out delta T. First of all, I would like to write down epsilon zz is delta T by T. And you know that can be written as sigma zz by E minus mu times sigma xx by E minus mu times sigma yy by E. And you know they have said biaxial, so sigma zz is 0. It is a plane stress condition. So now I feel very easily you can solve. This is becoming 0. You need to find out the delta T. Okay, this is also a previous year question of gate XC. So solve it, guys. This is question number 5. We are still left with 20 more questions. Okay, and tomorrow I would be taking a session on engineering mathematics in the evening, 9 p.m. for engineering services paper. That will be equally helpful for BARC exam, because in BARC also 2-3 questions are coming for maths. Solve it, guys. Solve it, solve it, solve it. Yes, everybody. Everybody. This type of question we have also seen in mechanical gate 22 paper. Okay. And this question particularly is from XCPYQ. Yes, very good. Solve it, solve it, solve it, guys. Solve it, solve it, solve it, guys. Solve it, guys. Tell me, guys. Yes, 5.25 microns. Okay. So let us see. I have also solved it for you guys. And the answer is coming out to be 5.25 microns, which is correct only. So I will be putting the values here. Delta T is, this is going to be minus mu times. Okay, minus mu will be coming common and divided by E will also be common. 200 into 10 ki power 3. You can write sigma xx plus sigma yy, that is 200 and 150. So 200 plus 150. When you will be solving it, it will be coming out to be 5.25 microns, because also this will be multiplied with the thickness which is already given as 10 mm. Okay, so answer will be 5.25 microns. For that, B is the right answer. Moving to question number 6, guys. This is from torsion. This is from torsion. Very good, Kunal. This is from torsion. This is from torsion. Solve it, guys. This question is from torsion. This question is from torsion. Solve it. A solid circular steel shaft of 50 mm diameter fixed at one end is subjected to torques as shown below. The shearing modulus of the material is 80 GPa. The maximum shear stress due to torsion in the length PQ is. So you need to find out the maximum shear stress in PQ. Let us take this to be first part. So you know the maximum shear stress formula is 16 T by pi d cube. Here torque required is the torque in PQ length. So solve this question, guys, and you will be able to answer it. Everybody, please solve it. Yes, everybody. Okay, Kunal, are you saying the answer B for this question? This is a torsion question. Please solve it carefully. So the answer for this question, we need to solve it. What is the answer, guys? So you know that if you are going to talk about this as 2, this as 3. If you take this as section to the right hand side, there is nothing. If you take this as section to the right hand side, it is 250. If you take this as section to the right hand side, there is 750. So first of all, TPQ is 750. I already told you direction plus minus does not matter here. It is 750 Newton meter. And you are given the diameter to be 50 mm. So you will be saying 16 into 750 divided by pi into 50 ka cube. And you would be getting the answer. This is into 10 to the power 3 to convert Newton meter into Newton mm. That will give you the answer in MPa. Okay, Kunal is saying C to be the answer. Divit is saying C to be the answer. Abhi is saying C to be the answer. Okay, Shreyas is saying 15.75. So answer will be C for this, 30.56 MPa. I feel Shreyas, you got your mistake. Answer will be C for this, 30.56 is the right answer. Very good, Ajay. Very good, Jisk. So moving further, guys, this was a good question from the torsion. I feel some of you have done the mistake in searching the torque in that member. So moving further, guys, before we go, if you want one-to-one counseling with our counselor, then you can also call this number, or you can fill the form, counseling form, which is available in the description of this session. Okay, and if you have made your mind to prepare for gate 25 or 26, our vision courses are live. You can enroll in that to get each and everything with the live classes, with the practice quiz just after every session, recording of those sessions, plus recorded lecture, plus study material, plus mock test. Everything would be there in this one subscription. Moving further, guys, moving to the next question, that is once again from engineering mechanics. Question number 7. A truss consisting of the member ADDC, AB, BD and BC subjected to a force of 120 Newton. The member ADDC and BD are each of 1 meter length. The magnitude of force in member BD, this is the BD member. You need to tell the force in this member. This is a very simple question, question number 7 from previous year's question of GATE. You can answer it very easily, very normally. So just try to solve it. This is engineering mechanics, guys. We have seen that solid mechanics includes engineering mechanics, strength of material and natural vibrations of single degree of freedom system. So this is the syllabus, and sometimes in the previous years Coriolis component of acceleration is also asked, because that can also be considered as the part of engineering mechanics. Tell me guys, what would be the answer? Jisk is saying 0. Okay, what about others? Shreyas, Kunal, Divit, Abhi. What about others? I want answer from all of you guys. I want answer from all of you guys. Yes, everybody. Answer is 0. Correct. You can see there are some rules. If we are having two collinear members like this, and at this point there is no force acting, then in the third member the force is going to be 0. Why? Because force in this and force in this are equal. So who will be balancing the force in this member? So here answer will be, this is a 0 force member. If you are confused into that, I have taken a session on YouTube over trusses. You can watch those sessions of mine. You will get all the ideas about the 0 force members. Answer will be A for this. Moving to question number 8. This is from Coriolis component of acceleration, guys. Coriolis component of acceleration. Coriolis component of acceleration, guys. Coriolis component of acceleration. A rigid link PQ is rotating and you are given a slider. Directions of velocity of slider is given. Rotation, angular speed is also given. You just need to solve it now. Solve it, guys. Solve it, everybody. You need to see which of the following is giving the right direction for Coriolis component of acceleration. So this is also a previous year question. So that's why I said you need to be prepared for engineering mechanics plus natural vibrations, that also for the single degree of freedom plus strength of materials. And here in strength of material also include theory of failure, because they are not considering that in the machine design. Okay, no issue Ajay. Abhi now solve this one. Previous one you can see later on. Okay. Okay, C. Ajay is saying the answer to be C. Okay. Divit was also saying C. First of all, I would like to tell you that we need to rotate the velocity vector by 90 degree, and I am making a watch first of all. You can see this is the direction of velocity given like this, and angular speed is given as clockwise. So when I will be rotating this 90 degree clockwise, it will be coming here somewhere. So velocity, this should be the direction of Coriolis for this case. So obviously this is a wrong option. If we are given velocity in this direction, and you know this is clockwise, so you know once again if you are going to consider the clock, this is for A, this is for B, you know this is the velocity, clock will go like this 90 degree. So in that case it should be in this direction, so that is why this is also wrong. Here if you will see, this is given anti-clockwise, so for this the clockwise was here, so anti-clockwise is here, so this is the correct direction. And if you see D option, it is anti-clockwise, so for anti-clockwise it should come here. This is going to be, okay, clockwise is there, anti-clockwise should be here, so D is also wrong. Answer is C for this. This is Coriolis component of acceleration. Moving to the next question, question number 9. This is from strength of material, also a previous year's question. So guys, this is from strength of material. They are asking you about the Mohr circle. Very easy question. And you will see the cutoff last year also was more for XC paper because paper was easier. So that depends. If paper will be easier, maybe this time also cutoff is going to be more than mechanical for that. But guys, the best thing here is you need to concentrate on less number of subjects. So JISC, which option is correct? They are asking which one of the following planes state of stress corresponds to the Mohr circle radius 0. First of all, I would like to tell you, they are talking about Mohr circle is converting into a point. This is not a case of pure shear, this is a case of zero shear because radius is 0. And 0 shear is coming in this case. Sigma, 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 sigma. Or the same can be in compression, sigma, 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 sigma. D is the right answer. Okay, for this D is the right answer. I feel you understood just your mistake. Avoid this mistake in exam. This is from theory of failure, strength of material, question number 10. So for XC paper, you cannot ignore the theory of failures. Question number 10. Maximum shear stress theory for material yielding is known as. They have just asked the name of the theory. They have just asked the name of the theory. That maximum shear stress theory was given by Tresca, von Mises, Saint-Laurent or Rankine. Okay, JISC is saying A, Abhi is saying D. Okay, Divit is saying A, answer is A. So I would like to tell you here, maximum principal stress theory was given by Rankine and Saint-Laurent have given maximum principal strain theory. Von Mises have given maximum distortion energy theory. So answer will be A for this. Moving to question number 11, guys, this is a numerical answer type question, and they are saying in a cantilever beam of length 2 meter. A cantilever beam of length 2 meter, the shear forces along the length is given as 5x square. 5x square, where x is the distance in meter measured from the fixed end. The magnitude of the load intensity at the midspan of the beam is. The magnitude of load intensity. Yes, guys. Try to solve it. Okay, try to solve it. First of all, they have given Vxx. You know that Vxx dV by dx is Wxx. So if you are saying dVxx, okay, if you are going to talk about Wxx, it is going to be 5 into 2x. This will be 10x. They are asking you the magnitude of load intensity. When you will put x is equals to 1, you will be getting the value as 10 Newton. Okay. But I feel whenever they are giving this type of question, they can also ask you bending moment, they can also ask you load intensity, and it would be a good question if they are saying that we are having a cantilever beam and that load which is 2x square is here, x is from the free end. Okay, and if they ask at that time where is the maximum bending moment, that kind of question would be a better one. Okay, but this is the PYQ, you know that. Moving to question number 12 from column now. This is question number 12 from column now, and I expect everybody would be able to answer this question very easily. Okay, this type of questions are also coming in engineering services paper as well. So try to solve it, guys. What they are saying is the buckling load of a cylinder column clamped at both the ends is 4000 Newton. This is clamped means hinged at both the ends. So they are saying that if we have a case like this, when it is hinged at both the ends, then the load carrying capacity is 4000 Newtons. And they are saying the column is subjected to an axial compression. During the course of service, one of the end gets detached from the clamp and becomes free end. The absolute percentage change in the buckling load due to the change in the end condition is. Okay, so when they are saying clamped at both the ends, yes. So try to solve this question, guys. Try to solve this. Whatever they are saying, according to that, second case should be this. Second case should be this. They are saying clamped at both the ends is 4000 Newton. The column is subjected to an axial compressive load during the course of service. One of the ends gets detached from the clamp and becomes free end. Yes, guys, solve it. So when you will be finding out the first one, pi square EI upon L square. Pi square EI upon 4L square. So P2 minus P1 by P1 into 100. 75%. Very good, guys. Moving further to question number 13. This is torsion support reaction calculation. Torsion support reaction calculation, previous year question, question number 13. So we have already crossed 50% of the questions. Solve this one, guys. Solve this one. Then we are moving further. Yes, everybody. A stepped circular shaft. You need to find out support reaction, but you need to see first of all what are the given things. They said that 680 Newton meter is the load, and they have said the diameter of portion AB is twice that of BC. The magnitude of torque reaction, they have said made up of steel. So G is same, J is not same. Okay, so shortcut is not applicable. You will assume this to be TA. You will assume this to be TC, and you have to make the equations like TA plus TC is equals to T is equation number 1, and theta AB plus theta BC is equals to 0. So you would be writing TAB, LAB, GAB, JAB, TBC minus LBC, GBC, JBC. So these are the two equations after solving which you will be getting TAB and TBC. Yes, solve it guys. TAB is nothing but plus TA. It is nothing but minus TC. Solve it guys. Okay, are you getting 640 and 40? Are you getting 640 and 40? 640 and 40. Okay, everybody is getting 640 and 40. Let me see. First of all, TA plus TC is equals to T. Let me write it. TAB. It is TA. Length is equal pi by 32 d ka. Pi by 32 d4 minus, this is TA minus 680, TA minus 680, then it is LG pi by 32 2d ki power 4. They are saying that AB is twice, the diameter is twice. GG cancel out, LL cancel out, D ki power 4, D ki power 4 will cancel out. Pi by 32 is also cancel out. So we are going to get TA is equals to TA plus 680 divided by 2 ki power 4. So when you will be having 17 times of TA, 680, TA is 40. So TA is 40, 40 and 640. Okay, they are asking the magnitude of torque reaction at spot at A and C. I feel 40 and 640, B is the right answer. B is the right answer, na? Have I done it correctly? Okay, sorry. I feel I have kept the diameter opposite. Yes. A is the right answer because I have kept diameter of this as doubled. A is the right answer. Yes, no doubt. A is the right answer, not B. Because why A is the right answer? I have taken the diameter here 2D and here D. Actually, it is here 2D and here D. Okay. So it is correct. Okay. So I would be doing it 2D ki power 4 here and D ki power 4 here. So in that case, this is going to be TC, or you can say TC is TC. So I am just writing it as TA is coming out to be 640. TC is coming out to be 40. I feel everybody understood. I have just kept diameter opposite, so answer could. Okay, Harika, just refresh your screen. You will be able to see that. This is from thin cylinder, guys. Strength of materials again. Thin cylinder, strength of material, simple formula. I feel everybody can answer it. After that, we have 10-11 more questions. I feel everybody can answer this question. They're asking you the increase in the radius of cylinder due to internal pressure. So they are talking about this a thin-walled cylinder with open ends. This is a very important word which will help you to find out the things. Both ends are open. Okay, so this is the key point of this question. Try to solve it. Everybody. Yes, guys. Do like and share the session, guys. For you guys only, we are coming for practice even one day before exam. Okay. I'm solving it for you guys. First of all, you need to understand that circumferential strain can be written as sigma circumferential minus mu times of longitudinal stress upon E. But whenever both the ends are open, longitudinal is 0. So this stress will be 0. So epsilon C circumferential can be written as what? This is the change of circumference, na? So this is delta of 2 pi r divided by 2 pi r. 2 pi r is the circumference, is equals to sigma C upon E. So you know that 2 pi will get cancelled out and this will be delta r by r. Sigma C is PR by TE. You need to find out the change of radius. They have asked change in radius. It is PR square upon It is ET will be coming out to be. This is a thin walled cylinder. Okay. So PR square upon ETC would be the right answer for this. Very good, guys. Moving further to question number 15. This is a good question again. Try to solve it, guys. Good question again. Try to solve it. A cantilever beam of length 3L, L, and L, subjected to two forces each of magnitude P. The flexural rigidity of the beam is EI. Assume linear elastic material and small deflections. Which one of the following statement is true? The magnitude of bending moment in portion AB is 0. Magnitude of bending moment of AB is PL. Magnitude of bending moment in portion AB is 2PL. You need to find out the bending moment in this AB part. That is what they are asking. If you are able to get this, you will get the answer. That is what they are asking. Magnitude of bending moment in AB part. Okay, options are option A 0, option B PL, option C 2PL, option D 0 to PL. Solve it, guys. Options are in front of you. What would be the answer, guys? This is question number 16, 15. Yes. Ajay is saying B, Jisk is saying B. What about others? Yes, everybody, please tell me answer. Jisk is saying the answer to be B. Okay. So guys, first of all, in CD there is no load. So if you are going to talk about the bending moment, this is, let us say 1-1. You can directly say M11 is 0. And if you are going to talk about M22, it would be coming out to be what? I am taking the distance from here, let us say. So it would be saying P into X minus L. Okay, this is sagging moment, so plus is coming. If I take a section at 3-3, so bending moment at 3-3 will be, it would be P into X minus L minus P X minus 2L. If you will see here, Px minus PL minus Px plus 2PL. Px cancel out. Answer is PL. It is independent of X. So answer is B. Answer is B for this. Moving to question number 16 for the same data. For the same data, I am making the figure. I am making the figure. You need to find out the deflection at B. You need to find out the deflection at B. You need to find out deflection at B. For that, what you will be doing? This is the beam. One force is already acting here. You will make the effect of this force P. When you will be making the effect of this force B, you can very easily do this. You can very easily do this. So what is the effect of this P? You would be saying this is the force. You will make one force here, one force here. This and this will be making the couple. So one force P here, one moment P into L here. This is A, this is B. I feel we can very easily find out the deflection at B. It is coming because of just B, P into L, because the effect of this and this will get cancelled out. You know the formula, ML square upon 2EI. M is PL. You can solve it very easily. Here M is nothing but P into L. M is nothing but P into L square upon 2EI. So PL cube upon 2EI. B is the right answer. Everybody got it? Moving further to question number 17, guys. Question number 17 is this. A steel bar of rectangular cross section is heated uniformly and the rise in temperature is delta T. The Young's modulus E, Poisson ratio mu, coefficient of thermal expansion alpha. The bar is completely restrained in the axial direction. I am making the question in front of you. There is a cubical bar in which the temperature is raised by delta T. Young's modulus is E, alpha is the coefficient of thermal expansion, delta T is the change of temperature, mu is the Poisson ratio. And they are saying that we are having the restrictions from all the sides like this, in such a way that the thermal stress developed in the bar along the direction you need to answer if it is said that restrained in the axial direction and lateral direction. Means we are not allowing any strain in any of the direction. What should be the answer, guys? If there is no strain in any of the direction, you can say volumetric strain because of free expansion, you will find out, and volumetric strain because of axial compression, you will find out, and volumetric strain because of thermal expansion and because of sigma component, this should be 0. Just equating it to 0, you will get the answer. I have given you the hint. This is a beautiful question. I have done many times in the classes, so everybody would be aware of this. Jisk is saying the answer to be A. Okay, what about others? Abhi is saying B, I feel so. Yes, what should be the answer, guys? Yes, guys. So first of all, I would like to tell you, due to thermal expansion, it is XX plus YY plus ZZ. You know, it is 3 times of alpha delta T. है ना? When we are talking about because of sigma, it is 1 minus 2 mu upon E. Sigma 1 plus sigma 2 plus sigma 3 is minus 3 sigma because it is compressive in nature. And you know the summation of these three is 3 alpha delta T. This is minus 3 sigma 1 minus 2 mu upon E. That will be 0. Sigma will be coming out to be what? 3 alpha delta T into E divided by 3 1 minus 2 mu. E alpha delta T 1 minus 2 mu. This is the magnitude and it is compressive in nature. So answer is C. Answer will be C for this. Everybody understood the mistake? Everybody understood the mistake? Arey bhai, all three are compressive na? Sigma, sigma and sigma. So that is why it is, you know the formula, 1 minus 2 mu upon E, sigma XX plus sigma YY plus sigma ZZ. So all are minus sigma minus sigma minus sigma. So answer will be C for this, and the same data is having one more question. Assume that the bar is allowed to deform freely in the lateral direction while keeping the axial direction restrained. In the previous case, you have seen sigma came out to be E alpha delta T divided by 1 minus 2 mu. This is the previous case. I am taking it sigma 1. Now they are saying consider a case where we are applying the restriction in X direction, but in other direction it is free to deform. And they are saying the percentage change in the magnitude of axial thermal stress. So you need to see what is the sigma 1 for this case. What is the sigma 1 for this case? What is the sigma for this case? So you know sigma for this case you need to find out. And then they are asking you the percentage change. So let us say this is sigma 1, or this is, let us say sigma, this is sigma dash. So you need to see what is the percentage change. Try to solve it, guys. Try to solve it. So it is sigma dash minus sigma by sigma into 100. I am giving you the hint. If you are having a bar which is fixed in axial direction For that, sigma is E alpha delta t. So you can simply say, for our case, sigma dash is E alpha delta t. And sigma is E alpha delta t divided by 1 minus 2 mu. The value of Poisson ratio is given to us. And you will be getting both the values, put it here and get the answer. Okay, you guys have given the answer as 25%. Let me see. So when you will put 0.25 into 2 is 0.5. 1 minus 0.5 is 0.5. So it is going to be 2 times. So it is I feel it should be 50%. C is the right answer. Thermal stress ने घुमा के रख दिया सभी को. Answer will be C for this. So guys, moving further to question number 19. Once again, it is from column. So guys, 6 more questions are left. Now questions I feel will be easier. The Euler's buckling load for a long cylinder column, fixed end condition. They have given for this condition. You know, for this condition, LE is L by 2. If the end condition are changed to fixed free, LE is, yes, L by root 2. Solve it, guys. Sorry, LE will be 2L, na? 2L. LE will be 2L. Solve it, guys. Six more questions to go, guys. अरे भाई ये फिक्स्ड फ्री है, फिक्स्ड फ्री. L is 2L. It is LE L by 2. Solve it carefully. You remember na, there are 4 cases. LE is L by 2. LE is L by root 2. LE is 2L. L is L. So when you will be solving this, they are saying the Euler's buckling load now. So if you are having pi square EI, L is L by 2, so L square 4. If this is 10,000, then second case is 2L. Pi square EI upon 4L square. That you need to find out. I feel it is 1 by 16th. A is the right answer. Very good, guys. Moving to question number 20th. Moving to question number 20th. This is the question from boundary condition. If anybody remember, when I was teaching you deflections, I always told you about the boundary condition. Try to solve this question, guys. If we are given a beam like this, force, this is not symmetrical loading. You need to find out where deflection will be maximum here. Where deflection will be maximum. Deflection is always coming to be maximum where? Loading is not symmetrical. Loading is not symmetrical. This is the mid span. If loading would be symmetrical, then maximum deflection occurs at mid-span. But if loading is not symmetrical, then maximum deflection will be occurring somewhere in between these 2 points. So answer for this should be A to L. Okay, this is A to L. A to L. Clear for everyone? Answer should be C for this. Okay guys. So moving further, last 5 questions in front of us. Question number 21, they are asking you the center of Mohr circle. Center of Mohr circle, guys. Direct formula you can use. They are asking you center of Mohr circle. For a biaxial state of stress, sigma xx 40 MPa, sigma yy minus 20 MPa, tau xy 30 MPa, the Mohr circle is having a center at. Where will be the center for Mohr circle, guys? I feel everybody know that. Center of Mohr circle is given as sigma star comma 0, where sigma star is written as sigma xx plus sigma yy by 2. 40 plus minus 20 by 2. Answer will be coming out to be 10, 0. C should be the right answer. Question number 22. This is from the velocity approaches. You can do it from the engineering mechanics point of view also. You can use it, the concept of eye centers. Okay. Eye center is also the part of engineering mechanics, not only for theory of machines. You know that if the velocity direction is this, you will sit perpendicular to this like this. It will be coming down perpendicular to this is like this. This is the eye center you will have. So velocity of t is given to us, which can be written as ti into omega ts or st. This is 6 meter per second. Ti, if this is 30, okay, you can very easily write ti and you will be getting omega st. Very simple question. Everybody, only 3 more questions are left. You need to find out omega st. Yes. Arey bhai, use the triangle. This is 2 meter. So this is going to be 2 cos 30. You can use it. Yes, C is the right answer. You will be getting omega st as 2 root 3. Question number 23, guys. Natural vibrations. A simple mass spring system shown has a natural frequency of 5 Hz. We have Fn as 5 Hz. The static deflection of the spring due to the mass is, you need to find out. Everybody remember, we need to find out delta static deflection of mass. Okay, that you know that the formula for static deflection, you know that from omega n is 2 pi Fn. It is square root of g by delta. This is the formula for relay method. So we can write the delta static as, what is the delta static? It will be 2 pi Fn ka square. Okay. You would be having 2 pi g by 2 pi Fn ka square. This will be delta static. G is 9.81. When you will be solving this, answer will be coming out to be D, 0.01 meter. You will be getting 0.01 meter. Very simple calculations. Answer is D for this. Very good guys, very good guys. Moving to further question number 24. 24 and 25 are from theories of failures. Last two questions from my side. A ductile material has a tensile yield strength of 200 MPa. Then you need to find out for this case. For this case, they are asking that if normally SYT is this, then the stress at yield under equibiaxial compression for this material according to Tresca will be. According to Tresca will be. Yes, try to solve it, guys. So you know that first of all, this is same nature. This is same nature or opposite nature. Same nature or opposite nature. For same nature, Tresca will be giving the same answer as that of Rankine. Okay. So as this is same nature of principal stresses, okay, here answer will be 200 only. This is the case when Mohr circle will be a point. The same data, second question is stress under pure shear for the same material according to von Byjus. I feel, you know, whenever we are talking about the pure shear, where sigma 1 is coming out to be plus tau, sigma 2 is coming out to be minus tau, then we know tau ys is become SYT by root 3. So answer for this will be 200 by root 3. So this is from the last part of theory of failure. I feel everybody understood this question. Okay guys, with this I have completed this session, and now I would like to say you all the best for tomorrow's exam in the second shift for XC paper. And जलवा दिखाना है कल आप लोगों को. You have to perform it nicely. Okay. And those who are preparing for engineering services, I would like to tell you guys that for ESC already paper 1 series is going on. In the morning 10 AM, you know that tomorrow SQP, statistical quality practices, would be live. You can join that session. Okay. Live means that will be premiered. Okay. And in the evening 9 PM I will be taking a session on engineering mathematics. Even if you are looking for bark paper, there also 2-3 questions from maths are coming. You can join that session. I will be solving 15-20 questions in that session. Okay, so goodbye for this particular session. Okay, and once again all the best for the exam. Goodbye.